Good afternoon. Since the last video, I've ended two of my long-term projects, so I'm no longer going to try and make a lightweight guitar for me to play stood up, and I'm no longer trying to make a guitar strap or harness system that lets me play a conventional guitar while stood up. I've been working on both of these projects on and off for about 6 years. The cause for me wanting to do these things was the problem that my injured shoulder isn't going to, it became apparent that my shoulder injury isn't going to recover to where I can just take a normal guitar, put a guitar strap on, and play it standing up. I can't do that because my it cuts off the blood flow to my left arm essentially. In the case of making the harness or some other kind of strap system, I've explored all of the techniques that I already know how to do. I'm confident that, firstly, that nothing I do have done has worked. Like, obviously, I can know that with certainty, but I'm also pretty confident that I can't make them work. Like, nothing I can think of should have a different result. So, you know, there is a path to take it further. But what I'd need to do is learn a lot more about human anatomy. So, exactly where the important blood vessels are. I might even need to get a CT scan of my own shoulder to because it's probably not where everyone else's is at this point. And then I'd need to learn the techniques of armor manufacture to build essentially some kind of pauldron that has the weight not on that important blood vessel into my shoulder, and then I could wear a normal strap over there. That's what I would have to do. Now, I reckon it would take me at least 9 months to a year of quite focused effort to learn enough of the skills to where I could expect to be able to make something in that line that I could test. And I think I can find other things to do with my time that I would enjoy more and would ultimately be more valuable to me than spending the time doing that. So, and also, like, as I say, that is the next thing that it would make sense to me to try. It doesn't mean that it would definitely work. So I'm looking at 9 months to a year, some possibility that that would conclude the project successfully, but no real expectation that it would. And on that basis, I'm not going further forward on that project. Now, the lightweight guitar project is a very different case. Um, I'm actually near certain that I know how to make what it would take to make a guitar body that would work for me. So I would have to get it contract manufactured, so made by someone who has the right machinery, and they'd have to make it out of 3D printed titanium. And the term for that is generally direct metal laser sintering. So it's sheets of thin layers of titanium powder melted with a laser to form the structure that you want. But because of that powder nature, you have to have like drainage holes for the powder and various other things just to make the process work. So my point is that before I can get to where I could ask someone to make me a 3D printed titanium guitar, I would have to learn enough about that process or the design constraints of that process to make it what I asked them to print possible to print, and um, I would have to then apply that to the domain of a guitar body. So I reckon at least 6 months to get to where I would have a CAD design of something that would be 3D printable in titanium and where I wouldn't know why it doesn't work. After that, I would expect to, I'd have to pay someone to make the part, send it back to me, wait for it to turn up. Um, then I would have to test it. I would then understand why what I asked for the first time does not work because I with any of these processes, it's spectacularly naive if you think you can uh, make something the first time with a advanced manufacturing process you've never seen and have revision zero be perfect. It could happen. Expectation is it wouldn't. There'll be at least a revision one, which is going to be another sort of 3 month cycle, and probably a revision two. I would expect, given my skills and track record, that I wouldn't need a third revision, and I might not need the second. But balance of probability for costing it out is I would need a revision 1 and a revision 2. So looking at least a year of work and 3 times asking someone to manufacture the part for me. And at the end, I would fully expect to have a usable instrument. So I think it's worth asking the question, why don't I do that, given I've already spent 6 years trying to do this? And like, why not spend the one more year? Well, I was happy with my investment of several years into learning how to shape wood and how to finish wood projects in order to make a wooden guitar body, because I expected that I would find other uses for those skills once I had them, and that was indeed the case. In the case of trying to 3D print them out of plastic on a FDM machine, well, I already owned the machine. I already had I already knew how to use the machine. I just had to do the guitar specific parts, which were not, not a big stretch, given I already know how to make guitars out of wood and I already know how to 3D print things that aren't guitars. Right? Is combining those two was not a great deal of difficulty, and so that was a low cost thing for me to attempt. The thing with the 3D printed titanium and the DMLS process and learning how that works and getting that done is those are skills I don't currently have. There's always some kind of desire to pick up new skills just in case they'd be useful. But I'm near certain that I do not want anything else made with this process, and therefore investing like basically a year on where that's the only I would gain those skills and hopefully get a working instrument out of it. That is not as good a deal as spending a year learning some skills I do expect to also use and getting an instrument that works for me at the end of it. So that's a large part of it. But there is another thing that's changed. So something that helped me decide to do all of this way back 6 years ago was the thought that perhaps there are other people out there with the same kind of injury or the same kind of problem from some other cause, but they don't have the resources to do any of the work to try and solve that problem for themselves. And like I do, so um, I can I can work on the problem, I can solve it for myself, and then I can make the solution available for others to use. Maybe that will help them in a way that could matter to them. Like it really still does matter to me to solve this. So like just the amount is not infinite, right? So, but what's changed is that as I've got closer to knowing that it can be solved, I've tried to find anyone else who has this kind of problem, and I've looked in all the places I know where to look, and I can't find anyone. So it doesn't, like, I'm not saying they're not out there, but there's functionally no difference between uh, they're out there and I can't find out how to tell them I can solve their problem, or they just don't exist. It's the same either way. There's no motivation for me to try and solve this problem because it will help others, because I know it won't help others, because I've tried to find anyone who I could talk to who needs the same problem solved, and they just don't exist in my sphere of ability to find them. So I can't, motivate myself to do this because it will help anyone else out. Because you know, my determination is that it just won't. So both of these projects are failures. That's why the video is titled "I'm declaring failure." The basic definition in my mind of this kind of project is you have a problem, you start a project to solve it. There's state machine, then it has three positions it can be in. The project is ongoing, the project has succeeded, or the project has failed. Now you know if the project is ongoing because you're still doing it. You know if the project has succeeded because you haven't got the problem anymore. And the third state of failure is everything else. So I started this project. I'm not doing it anymore, so we're not ongoing, and um, I still have the problems I had when I started it. So we're not succeeded. Therefore, these projects have failed. And I think that we don't in business talk about what the failure criteria of a project should be enough. We talk about success criteria, but we don't tend to tell people who are working on it, right, here's how you can know that you failed and you should stop working on it. And I think that is actually a mistake. So looking back on my time doing these projects, I don't think it would have made any difference if I'd thought, been more explicit about the failure criteria, because I don't think I could have done things in another order. But I can see the situation where, like, it's very possible that you can know, like, here's what success looks like, and here is what failure, like, definitely we're just going to stop and not solve the problem if we get into this region. And if you're in the, in that big zone where all of those things are possible, that your error bars on your project are as wide as they can be, with like they are at the start of a project, you can do some exploratory research and determine that maybe success can't be reached, because if that was, if where you want to be was possible, you would be able to do this small part, and that small part's impossible, and then you can stop. And that is something we routinely do already. But the other thing you could, if you knew, like, more explicitly, we're not going to do it if it involves, in picking the example in this case, I'm not going to do it if it involves more than 9 months of work acquiring skills that I have no other use for. If I could, so there's a relevant question: was there a point earlier in the project where I could have done some experiment that was not actually on the path to success, but that would tell me, am I definitely going to end up having to do something that will take more than 9 months learning skills I don't have any other use for? Because if I can prove that that's the case, then I could have stopped earlier. Now, in the case of these projects, looking back at them, I don't think there was a shorter way to find out, um, that I would have to end up, needing DMLS titanium. I do wonder if some of the projects I worked on in industry that ended up stopping it without solving the problem, if there would have been a way to fail them faster and therefore save a lot of wasted effort and money, if we'd been more clear with ourselves about what we will later, what was always true about the business's risk appetite and whatever. But if we'd known that and thought, hold on, can we do something to know that we definitely are or maybe are not in the definitely will fail side of things, and then choose to do something differently? um it's an interesting question to me. I do want to mention a couple of, like, much more minor projects that have, like, I've started these since the last video and then decided not to pursue them. um I thought it would be cool to be able um to have a headphone out socket on my guitar and connect it with a single cable to my laptop, which is going to run some kind of, guitar effects chain signal simulator, and then have the audio from that sent back to the guitar body and then out of the headphone jack into in-ear monitors that I'd be wearing. So I'd have a wire from my ears to the guitar and a wire from the guitar to the computer. And I could think of two ways to do that, so I tried them both because why not? So the first way, I used the power that is supplied to bias a microphone from the microphone socket of my laptop. Um, I used that to power a buffering op amp, and then just, like, passed through the headphone um, connectors to my earbuds, and that worked to an extent. It works if you use a very low gain signal chain, but as soon as you get any appreciable amount of gain, I start to get horrific feedback, and I spent a couple of days debugging that on breadboards, um, and I got it to where I had proven to my own satisfaction with oscilloscopes and multimeters and whatever that the problem was not an oscillation in my op amp circuit or a feedback in the guitar circuitry or anything like that, but that it was a um, entirely driven inside the inside the circuitry that drives the headphone and microphone out on my laptop. That there's a the driving the headphones with the signal creates a the chip that does that creates a ripple on the power supply, and that ripple is interpreted by the microphone chip indirectly as a signal for it to amplify. And so once you pass a certain amount of gain, that becomes uh, ludicrously screechy. So that was I was actually amazed that the system worked as well as it did, because you shouldn't be able to run much of an op amp buffer off of the 2.3 volts that my laptop outputs to bias a electret microphone. It really shouldn't be possible to run an op amp off that reliably, but it works fine. Like the modern ultra low power rail to rail op amps are really something special compared to what we had even a few years ago. Um, anyway, and then the second idea I had for how that could work was, okay, I could put a USB, the same chip that goes into like a USB headset. So it's got 2-channel digital to analog converter and a headphone amplifier to drive headphones, and it would have a single channel input that's designed for a microphone, but actually almost all those chips, and certainly the one I bought, have a mode switch for, do you want it to be effectively line level or do you want it to be microphone level? So I'd set that to line level, and then I could power my op amp off the same power source as the chip, which is of course a USB's 5-volt voltage. And so I tried to prototype that on a breadboard, because I didn't want to get a PCB made when I know like it probably just won't work for reasons I don't yet understand about USB. And it indeed doesn't work for a predictable reason, a reason that I would have predicted in advance and did, and so I wasn't surprised. So essentially, with the breadboarding layout, I couldn't get the data wire differential pair from the USB socket to be, that signal wasn't going to be coherent enough to run the DAC chip reliably. So I got it to where it worked well enough to initialize the ADC and the DAC, but then it would just drop off the USB bus with a desync problem. And as I say, I expected that. I couldn't solve it with the without making a custom PCB to run the differential pair as a proper signal. But as far as I could tell, other than that problem, I had the ADC and the DAC working broadly correctly. The problem I had was need quite a lot of capacitance to buffer the power for the op amp so that you don't get power supply ripple problems affecting the audio. And then you need to do something about protecting the USB host from the current that those effectively open circuits of capacitors will suck as you first plug it in. It's a sort of slow ramp ICs exist to solve this particular class of problem. So that is what I would have had to use, and I've never used those before. I didn't have any to hand, so I thought, okay, I already decided I don't care enough for this to make a totally custom PCB, so I'll stop it there. I think it's an interesting product idea. I wish if it existed, I would probably buy one, because it means you can have it means you can plug a guitar into a computer with a USB-C cable, and have it just be the dry signal of the guitar straight in, and you'll get back out what the computer has rendered as audio. So you could play backing tracks, you could play along, so you can have whatever simulated effects chain you want in the computer, but you aren't really tying the guitar to sort of technology that's going to go out of date in 5 minutes. It's not like the guitars where you embed an effects processor, or you embed Bluetooth in the guitar, or whatever. USB audio has been, for that number of channels, has been USB 2 since it existed. There's certainly enough bandwidth. There'd be no need to replace it to USB 4 or 5 or 6 in the future. It'd be utterly unnecessary. So um, I think it would be an interesting circuit for someone to make. I've just decided it's not going to be me. On that note of, well, on that list of failed projects, or projects at least that I'm not pursuing and the problems are not solved, I will say goodbye. Thank you for listening. I hope it hasn't been depressing. Sorry if it was. Anyway, cheerio. Way things are going, I'll see you in a month or so. Bye bye.